So we are now on page 2. So I'm going to start with number 12. It says solve this system by graphing. Well, I'm going to graph the first equation. It says I want the x values that are greater than or equal to negative 4. Well, here's where the x values are like 1 and 2 and 3 and 4. Here's negative 4 right here. Well, all the x values that are equal to negative 4 are right along this line here. It could be negative 4, 1 or negative 4, 2 or negative 4, 3, but the x values on this line are always negative 4. So it's this line, but I also want to include the x values that are greater than negative 4. Well, the x values that are greater than negative 4 are always to the right, like negative 3, negative 2, 1, 2, 3, 4, all of these. So I would shade everything in this direction. Then it says to graph, or I want the y values that are less than 1. Well, here's where the y values are 1. Here's where they're 2 and 3 and 4, but along this line they're all 1. Now, I don't really want the y values to be 1 because I just want them to be less than 1. So I'm going to put a dotted line here, but I want them to be less than 1, which is everything below the line, which is down here. So the solutions that satisfy both of these graphs are anything that's shaded twice, which is all of this stuff in here, plus anything that's on this line. And that graph represents the solution set that includes all of the solutions of those two inequalities. So 0, 0 would be a solution. 2, 0 would be a solution. 2, 2 would not be a solution. 2, negative 2 would be a solution. So we just need to make sure we know what all the solutions are. Let's move on then to number 13. So we're going to solve this system, and we're going to solve this system using one of two methods. We can either use substitution or we could use elimination. And I think what I'm going to do here is use, maybe I'll use elimination, which means I want to eliminate the same variable twice. So I'm going to start by using the first two equations here, and I'm going to eliminate the y's, I think. So I'm going to start by taking the top equation and multiplying it by 3. So then it's going to be 3x plus 6y plus 15z equals 3. Then I'm going to multiply the bottom equation by negative 2, or the middle equation by negative 2. So then this is going to be 6x. 3 times negative 2 is negative 6y. 7 times negative 2 is negative 14z. And 4 times negative 2 is negative 8. The reason I did that is because now my y's are going to be eliminated when I add these two equations together. I will have 3x plus 6x, which is 9x. 15z minus 14z is plus 1z. 3 and a negative 8 is a negative 5. And there's one equation. So I'm going to go back to my original equations, and I'm going to eliminate a y again. Except this time I'm going to use the top equation and the bottom equation. So I'm going to start by multiplying the top equation by 5. So it's going to be 5x plus 10y plus 25z equals 1 times 5 is 5. And then I'm going to multiply the bottom equation by negative 2 so that the y's will cancel. Negative 8 times negative 2 is 16x. 5 times negative 2 is negative 10y. 12 times negative 2 is negative 24z. And 11 times negative 2 is negative 22. And now when I add these together, those are opposites. They're going to be eliminated. I will have 5x plus 16x is 21x. 25z minus 24z is just plus z. And 5 and a negative 22 is a negative 17. So here's my second equation without a y in it. And it works out kind of nice because I have a z here and I have a z here. I'm just going to take this equation here and multiply it times negative 1 and move it over here. So this is going to be negative 9x minus z equals positive 5. So now when I add these together, the z's are going to be eliminated. I'll have 21 minus 9 is 12x. The z's are gone. Negative 17 plus 5 is negative 12. So if I divide both sides by 12, x is negative 1. Now I'm not done because I need to figure out what the x, or the y and the z are. And so I'm going to use this equation right, let me go up, I know what x is. I'm going to use this equation right here. Let me use this one here. I know that x is negative 1, and so if x is, I can use either one. Let me use this one. I know that x is negative 1, so 9 times negative 1, that's negative 9, plus z equals negative 5. Well, I'm just going to add 9 to both sides, so that's eliminated, and z equals negative 5 plus 9, which is 4. So now I know that x is negative 1. I know that z is 4. I just need to figure out what y is. So I'm going to go back to one of my original equations. I'm going to use the top equation here, and it says that x is negative 1 plus 2y. Now I don't know what y is, so I'm just going to leave it plus 2y. Plus 5 times z. Well, that's 5 times 4, which is 20. That equals 1. And now I'm going to solve this equation for y. I'll have 2y plus negative 1 plus 20 is 19 equals 1. If I subtract 19 from both sides, then I'll have 2y is equal to 1 minus 19, which is negative 18. And if I divide by 2, y is negative 9. And so my solution is that x is negative 1, y is negative 9, and z is 4. Let's take a look at number 14. We're going to divide. We could use long division, but I'm going to use synthetic division here. I'm going to put a 2 here because it's x minus 2. My 0 would be 2. Then I have a negative 2x to the third, a positive 2x squared, a negative 7x, and a positive 15. And I'm just going to negative 2. I'm going to bring that down and multiply it times 2, which gives me negative 4. 2 and a negative 4 is negative 2. If I multiply that times 2, I get negative 4. Then I'm going to take negative 7 plus a negative 4, which is negative 11. If I multiply that times 2, I get negative 22. And then 15 and a negative 22, that's a remainder of negative 7. So when I divide that, I will have negative 2x squared, that's this, minus 2x, which is this, minus 11, remainder, negative 7. That's number 14. Number 15, we want to solve this system of equations. We could use any method that we want, but I think what I'm going to do is I'm going to take this top equation and just multiply it times negative 1, so that the 2x will become a negative 2x, the negative 4y will become a positive 4y, and then the 12 will become a negative 12. So now when I add these equations together, the x's will be eliminated. 2x and a negative 2x is nothing. Negative y plus 4y is 3y, and negative 3 and negative 12 is negative 15. And if I divide by 3, that means y is negative 5. So if y is negative 5, let me use this equation here. This means that 2x minus negative 5, well, that's plus 5, equals negative 3. And I'm going to solve for x. I'm going to start by subtracting 5 from both sides. So 2x equals negative 8. And if I divide by 2, then x is negative 4. So I get negative 5 for y and negative 4 for x. Let's take a look at number 16. This is probably one that you might have a question about because it's one that we didn't really go over that much in class. So this is an important one here. Number 16 says for the polynomial function pictured, state the intervals of the domain, so those are the x values, for which the graph is increasing or decreasing. Well, an increasing graph, we read from left to right. An increasing graph means that it's going up. So it's going up from here to here. And then it's decreasing from here to here. And then it's going back up from here to here. So there were two places where it was increasing. Okay? So the intervals where it's increasing is going to be from negative infinity. I'm going along the x-axis. It's from negative infinity because this goes down forever. It's going to be increasing from negative infinity all the way until x is negative 3.667. So we would write that like this. Negative infinity to negative 3.667. That's when it's increasing. It's also increasing from this point, which the x value is 1, and it increases as we move over to the right. It increases forever. So it'll increase from 1 to infinity. Those are the intervals where the graph is increasing. There's only one part of the graph where it's decreasing, and that's from here down to here. Well, that is from when the x value is negative 3.667 to when the x value is 1. And those are the intervals where it's decreasing, or decreasing here. Let's move on to number 17. A model for a company's revenue from selling a software package is given by this function, where P is the price in dollars of software. What price will maximize the revenue? Well, here's what we know. If they give it away free, they're not going to make any money. If they start charging, they're going to start to make money. But if they start to charge too much, people aren't going to buy it, and they're going to get back to making nothing again. This is a quadratic equation that opens down. It looks something like this. Here's the price here, and here's the revenue here. That's the y-intercept. They want to know what value gives you the maximum revenue. That's the vertex. So what we're looking for is the vertex. You guys are going to have your graphing calculators on your test. You could just plug that in, plug this equation in, and find the relative maximum. Or you could do it the old-fashioned way, which is to use negative b over 2a. There is no c value here. The negative b is going to be negative 500 over 2 times negative 2.5. Well, that's negative 500 over 2 times negative 2.5 is negative 5. Well, that's going to be 100. That means the price should be set at $100. Now, that's not the maximum revenue. The revenue is going to be the y value that I get when I plug 100 in for P. That would be one way to do that equation. Let me show you how to do this on your calculator, too. Let me change the window again back to negative 10. This is where most of you will have it start anyway. Negative 10, negative 10 to 10. And then the y value goes from negative 10 to 10, and we're going to count by ones. And if I plug this equation into my calculator, I would have negative 2.5x squared, and then plus 500x. I'm just plugging this in for y. My p becomes my x's, and my y1 is the revenue. And so then I want to graph this. So I know that I'm going to have to go all the way over to 100 already. So I'm going to make my window go from, let's just make it go from 0 to 200. And I'm going to count by 50s. But the revenue is probably going to be more than my maximum of $10. I want to make more than $10. I want to make this really a big number. Let me just say 5,000. I'm going to count by thousands. Maybe 5,000 isn't going to be enough. But if I graph it, see it went up. It's still thinking over here. And then it came back down. 5,000 isn't enough, which actually would be a good thing for this company because they want to make as much revenue as possible. So I'm going to go back to the window. 5,000 is not nearly big enough. So I'm going to say, I don't know, 5, 1, 2, 3, I'll add another 0, maybe 2 more zeros, and count by whatever that is. Okay, so I went too high. So let me change this so that we can see what this looks like. I'm going to take one of these zeros away. It's going to be, this is 5, I'm going to go 50,000. I'm going to count by 10,000, so maybe this will look a little bit better. Okay, perfect. So what I want is the maximum revenue, which is that point there, the vertex. I'm just going to go second calculate. I want to find the maximum value. So I'm going to move my cursor to the left and press enter. I'm going to move my cursor to the right and press enter again. I don't know how clear this is showing up on the video, but when x is 100, my maximum revenue is $25,000. And that would be my maximum revenue for number 17. Let's keep going here. Number 18. Find the y-intercept of the graph. Well, whenever I have a y-intercept, the x is equal to 0. So it could be this point, which is 0, 1, or 0, 2, or 0, 3, 0, 4. It's 0 something. So to figure out what the y-intercept is, I'm just going to let x be 0. So if x is 0, 0 minus 1 is negative 1. Negative 1 squared is 1. Times 2 is 2, and 2 plus 7 is 9. Okay, so it might be 0, 9 if you write it as a ordered pair, or the y-intercept which just crosses at 9. And then number 19, write a quadratic function in standard form, then identify the quadratic linear or constant terms. So I'm just going to have to FOIL this. I'm going to take 4x times negative 3x squared is negative 12, or negative 3x is negative 12x squared. 4x times negative 5 is negative 20x. 1 times negative 3x is negative 3x. 1 times negative 5 is negative 5. So my final answer is going to be negative 12x squared minus 23x minus 5. My quadratic term is this, because it's the quadratic. My linear term is negative 23x. My constant term is negative 5. And that is page 2.